there's got to be a legitimate way to approximate things to greater accuracy than guessing what they want us to do is find the first four non-zero terms of the binomial series centered at 0 given the function and use those first four non-zero terms to approximate the given quantity. So when we're looking for Taylor's series for this binomial series centered at 0, I guess it's a Maclaurin then, we need derivatives. So we go and we take the first derivative, take that and rewind it back. We get the second derivative, take that and rewind it back. This is ludicrous. And we take the third derivative, take that and rewind it back. Don't forget to multiply it by the derivative of the inside using that chain rule. But the derivative of the inside is 1, so we're done. Now what? It's centered at 0, so we're trying to find this Taylor series for that, and we evaluate each one of those at 0. So faux show f of 0 is 1, because that's 0 plus 1, and then that's to the minus 2, it's still 1. Okay, and then we put a 0 in there, and then that's a 1 to the minus 3, so that's a minus 2. And what we do is we're getting the coefficient on that expansion for this binomial series. So if we were going to write out the first four terms, that k is equal to 0 to 3 of the kth derivative of f evaluated at 0 divided by k factorial, and then that's x minus 0 to the k. So I'm just going to trot those out. That's f of 0, f prime of 0, f prime prime of 0, and f prime 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 of 0. And then we do work, son. F of 0 is 1 divided by 0 factorial is 1. X to the 0 is none, so that's a 1. Then what? That's a minus 2x, because I put that in there. This one a little bit slower. Okay, f prime prime of 0 is 6. We saw that. Here it was sick. Okay, so then divided by a deuce, that's a tray. Okay, move that over there. All right. F prime prime of 0, that's a minus 24. That's this right here. Okay, and then we divide it by 3 factorial, which is 6, and on a good day, that's a minus 4. Sure. Take that, stick it over there, and let's make some room, because now we're on to part 2. Part 2, we're going to use the first four non-zero terms of the series to approximate. What the heck is going on there? Whatever it is, it needs to go on faster, faster, faster. Obey your... That's what we have. The first four terms of our master series for that binomial expansion. We're going to take those first four, and we need to find out what our x is. We see they want us to approximate 1 over 1.21, which is 1 over 1.1 squared. And I know you're like, oh my god, this is freaking me out. It just looked like one of those clowns or something. Okay, so I have what's in here. That's why I'm using the 1.1 to find my x. So then I have 1 plus x is equal to 1.1. Then I find that my x is 0.1. So everywhere I see an x in my binomial expansion, I can put a 0.1. Then I pound that out, and George's substitute came up with 0.826. Sick! And then we even checked it with our calculator, which uses a very similar process to this one to compare roots, and our calculator confirms.